gifting, and we offer diversified learning solutions. We are excited to have you all of you here for this informative webinar. Today, we are joined by an industry expert with over 20 years of experience in the IT field, Chaitanya, a highly skilled technical trainer, consultant, and mentor with a deep background in broad range of cutting-edge technologies, including cloud computing, DevOps, Kubernetes, Azure DevOps, AI, and much more. Chaitanya brings a wealth of knowledge that will help you navigate the complexities of modern IT landscapes. During today's session, Chaitanya will share valuable insights into Kubernetes along with practical strategies and best practices that can be immediately applied on your own environment. So, we encourage you to ask questions and participate actively throughout the session. Now, let's dive right into the session. Yes, over to you, Chaitanya.
Yeah, thank you, Supriya. So welcome everyone for this workshop on automating Kubernetes with Terraform. So what I'm going to talk about today, I'm going to first talk about the need for automation in deployment in DevOps. Then we'll learn very brief about Kubernetes Terraform, quick, and I'll talk about how we can automate deployment of Kubernetes using Terraform. I'm going to use EKS for the demo. And the end, we'll learn about some best practices and consideration in summary. Could you all go on mute, please? Yeah, so this is the agenda. So before I get started, is my voice clear, everyone? This is confirmation.
Yes, Chaitanya.
I feel it's
Yes,
good.
Chaitanya.
The first reason we're looking for automation is because, for example, in a DevOps world, we do lots of releases. And whenever do any release, we want to ensure that it is always correct. So no errors we're talking about. We want the releases to be quicker. And we work on different environments and enterprises. For example, we release application dev environment, work on test, we release applications in pre-prod, as well as the prod. So now across different environments, when working across, I'm looking for automation. So this is one more reason why I'm talking about automation. Then if something happens, let's consider that you updated a application to version 1. Running on 1.0, you made the changes to 2.0. If some challenges are there in the application version 2.0, you might want to roll back. And what if the application goes down? You might want this application to be up and running in a different data center or in different regions so that applications of customers is not affected, as you're talking about. And how we can automate the release. I'm talking about the build, test, then deployment, all these using your CI/CD pipeline, talking about your automation. And making these automation also helps folks to concentrate on the application part, and hence they are able to generate more revenue for the company. And we're also looking for automating the security operations. So example, if something happens, you want to automate, could be that some alerts and notifications using which we can do the remediation quickly. So these are the important reasons why enterprises are looking for using automation methods. And today, we're going to talk about automation of using Kubernetes with Terraform. So before we get started with what is Kubernetes, you need to understand what's a container. Yeah. So very brief, let me talk about container and how do we manage using Kubernetes. So Kubernetes is one of the leading container orchestration software. So what do you mean by container orchestration? So in very brief, for example, in a weak container, and how does a VM look? In a virtual machine, normally you would have in the OS, and then we go inside, log into the VM, and then we deploy the application data, whatever libraries, all those, what you want. So if you consider a developer, you did this work. So as a developer, your work is more into applications. So why are we wasting time to create OS, manage these, and then log in to the application, do the work? You prefer to have a ready application. So that is where we use containers, which has ready application, binaries, and libraries. So simple example is, let's consider that you want to work on Apache. So Apache is could be like this, or we can say HTTPD. So this is going to take a longer time if you want to use on, for example, a front-end developer, and you want to work on the front-end code. So you need to install the software on a VM. Then you have to install libraries, binaries. You might have to also configure the index file. Then you might have to modify the http.conf, all this supposed to do. But in a container, you not do it, because in the container, we normally create containers using some ready images. So example, we use a Docker image. And that particular image has all the libraries and binaries which you can start using across. So containers are application ready, and we can quickly start running your applications or log into it as a container. Yes, are we all good? Just want to understand this. Are we good with what's a container, everyone? Make sense?
Yes, Chaitanya.
Yes. So now how do we manage these containers? So in any enterprises, we would need to have in your applications running across multiple host machines for redundancy. So this is a host one, for example, and this is a host two, host three. So we first install something called as a Docker. So on, for example, this is your mission. We install Docker, could be on a VM, for example, and then you create containers. So I create 2 containers on this, and this is running your application. Now, to ensure that it is highly available, I also would have the same application running across multiple machines. So even if this host machine goes down, the application is still running on these 2. This is good, but who monitors these? They require some help. This is where we have to use a better mechanism, is a cluster-based, which is called as a master. And this master is responsible to manage these backends, to schedule containers or pods we talk about. And these would again consist of some components, these called the management containers. So example, like schedulers, they have API, they'll be having controller manager, code databases, all these. And if you work in a company, like if you work for ABC, for example, it's not a good practice if you're a DevOps engineer to directly log in to the backend, because this is highly critical, secure information. So you would log in like a jump server to log into the manager, and the request goes via the manager to the backends. So in this, so for example, in here right now we have 4 VMs. In each of the 4 VMs, you have to install a container platform like Docker, and then create containers. And any request would go to the manager component. So this type of combination of a master and the slaves, or we call it worker nodes, is called as container orchestration. Yeah. And we have different technologies for doing this. One among the famous or more of open source is your Kubernetes. We're talking about this. Yeah. So in very brief, Kubernetes is an open source platform for managing containers, which is running on multiple nodes. And this was first invented by Google, and then it was acquired by CNCF. It means open source. And since we can open source, we can use Kubernetes on premises. We can use Kubernetes with hybrid platform like cloud platform, or with a cloud like AWS, then Azure, GCP. In all the platforms, we can either use using IaaS platform, or we can deploy it using a PaaS software. Example, in AWS, I can either use EC2, in which I can deploy Kubernetes, or I can use EKS, wherein the managed nodes are, nodes are managed by your AWS. So container orchestrations. So what are the features? Let's look at the website of Kubernetes. So I'll be asking questions. You can ask questions in the meanwhile after every subtopic. The website of Kubernetes, also known as K8s. It's an open source system for automating deployment, scaling, and containers. So why talking about containers at Kubernetes? Because example, let's consider you're watching IPL match. At the end of the match, you have lots of viewers and enterprises require, obviously the load is increased. So if you use Kubernetes example, we can increase the workload, or you can say the scale up to 100 pods, and 100 application will be up and running quite quickly. So this is one of the important reasons why enterprises prefer Kubernetes, because for scalability and stability. So this is your website. So we can run anywhere, could be on premises, could be hybrid or public cloud, and preferably these are the important reasons. Example, let's consider that you are having an application running it. Yeah. Let me talk in very brief. So in Kubernetes, we talk about a concept called as a pod. So in a pod, the pod would look something like this. In a node, for example, this is a node, the backend node, or we call it slave nodes. We can have multiple pods. We cannot directly create containers in Kubernetes. So you create a pod, could be a pod 1, and this would have a IP address. And we can have multiple containers inside this. And all these, both the containers would be hosted or exposed to this IP address. This is what's the pod. Now let's consider that I want to update the pod to a different version. So it could be this pod version application was version 1.0. I can do to version 2.0 much easier without much of downtime. And I can roll back to previous versions if you have any challenges. It's got rollback. Second, we have different strategies. For example, we can use blue-green strategy. We can use canary strategies. Lots of different methods using which we can do A/B testing. Different methods using which we can do a deployment and updates. The first one. Second feature is this pod is temporary. If you delete the pod, I lose the data. So I can having the data of this to be mapped on the host. For example, we can have a volume in here, or we could also have a volume outside on the cloud and have it extended. So we can use like a shared volume like NFS, or we can use a volume on the host. The second feature. Third feature is they also call it something called as a self-healing. So self-healing is example, let's consider that you have multiple pods and one of the pod goes down, they come up automatically. So these are some of the important features why Kubernetes prefers or it being used in enterprises. We're talking about those in here. First one is you can deploy easily and quite scalable. So if you have 2 pods, I can say the scale up to 10 pods. It scales up in a minute. And we can do a load balancing. We have services method using which you can map the backend in static IP. Self-filling, if the pod goes down, they come up automatically without any human intervention. We can use rolling updates and rollbacks. And we in Kubernetes everything using IAC code. So what is IAC on a very high level? Whatever configuration you are writing in, you can write in a code like a JSON format or YAML format. So these are some important features. So how does it work, Kubernetes? So in enterprises, we talked about you have master, this is your backends. So if you're a DevOps engineer, this is your client, and this is your master, and these are different pods. The first main pod is API server. In Kubernetes, every component is behind an API. So a structure, for example, you have a structure like this in which you have v1. You will have some app/v1 like structure. So your pods, so we have different objects in Kubernetes like pods. We're talking about deployments. We're talking about services, what we have in containers like volumes, containers, similarly multiple objects. And each of these components are behind a specific structure in the API. So if you want to speak to any component, it has to go through an API. So we normally refer the first line in any of the YAML file to create any object API version like v1. And then I say a kind as a pod. That's an API. Second one is if any component needs to talk to any component, they have to go through API server. So API server is the front end for DevOps, as well as for any of the components interact, they have to go through API server. This is a pod. It has multiple containers. Second important component is scheduler. So scheduler is, example, a DevOps engineer, you want to create a pod. The request goes to the API server, and then the request goes to the scheduler. Now, scheduler needs to look into the request, and it might have to work with database, etc. the database, and based on the different requirement, could be some policies, it decides which node, could be one node or multiple nodes. This is how a scheduler decides, and then it goes to API server, and the API server sends the request to kubelet, and then the kubelet creates the pod and the container inside. Yes, are we good? If you have, I think you can ask questions now. Is the flow clear about how the pod gets created? Yes, no? Are we good? Everyone? Okay. I understand it's silent now. I think let me go ahead and proceed. The next component is just controller manager. So what is controller manager? So example, right now, you see there are 6 pods. Now let's consider one of the pod goes down. So kubelet is a component with the agent. It keeps on checking whether the pod is what happened. So as soon as it understands that there is a problem, it informs to API server, and it has to go to a component called a controller manager. This is the main component. And in this component, there is one more object which is managed called a replica set. And this component would remember the current value. So current was 6 before, and it was this before. So right now we'll understand that current equal to 5. It means current value is not equal to desired value. So now it has to help. So what does it do? It again go inform the API server there's a problem. It takes the help of scheduler, and then the request would again go back and create a pod immediately. This is called a controller manager. This is one example. Apart from this, if a node goes down or the load is too much, this component will come into the picture. Yeah, this is about a controller manager. Third component, or the fourth I'm talking about, is a etcd. This is your database. So this is a NoSQL database. If you want to think about, you can think about like DynamoDB or Cosmos DB in your cloud. So this stores all the metadata configurations, like what type of CPU, then memory, those information will be saved in the etcd. So these are important components of your master. So how do the DevOps engineers interact with the master? You have to use a command line interface called as a kubectl, or we can use API method using Ajax. The backend consists of kubelets. So these are responsible for the agent. They create a pod and they create the container inside it. And how the traffic comes from outside world? The traffic comes via the network rules called as kubeproxy. So kubeproxy is a component which has the network rules, and we define some policies, services, all this to work together using the traffic goes to the appropriate backends, or within the cluster we want to have a firewalls, we use kubeproxy. So these are important components of your Kubernetes. So Kubernetes does not have the own network. So we have to use open source network like VNet, Calico, and then we also have, I think, Planel. These are different networks which need to update it. And the pod would get IPs from this network. This is very brief about how Kubernetes architecture works. So let's see some information about it. I'll also give a link to you so that you understand this. Could you all please access this link? Any questions? Could you access the link? And in this link, you will have all the components we're talking about. What's a master? What's a cluster? So control plane is also referred as a master components, like your scheduler, then API server, and control managers part of control plane. And the backend machine or the work controls. And this is your main component. The front end is the API server. ATCD is your database. Scheduler decides where to create the pod on which node. Control manager helps to manage the control or talking about operations. That can extend to cloud. And every node, or including the master, consists of kubelet, which are the agents, which would deploy the pods, the container. They also do the health checks. Proxies for firewall rules from outside as well as internal. Container runtime means how do you manage the containers? We can use Docker, container, either multiple platforms. So these are the important components makes your cluster. And apart from this, we can also use DNS. So DNS is for resolving to IP addresses. We can work with Kubernetes using your GUI method for the web UI to monitor using Prometheus and Grafana, or we can use ELK for your logging. So you can deploy these, integrate these with Kubernetes. Kubernetes is very open source and lots of things you can integrate with Kubernetes. Okay. Now, how do we get started in Kubernetes? So we have to do some deployment. So for example, I want to create 3 pods of Nginx. This is my use case. So how do we do it? So you have to do something called as an API version. I'll show an example about it. So you create a deployment object in which you say how many copies you require, and these gets created in the backend node machines. And deployment is the method what we use in enterprises to ensure that it creates a multiple nodes automatically. So for example, if I say replica has 6, you see here 2 goes each one. So it's 6 copies as created. And this pods will first create a replica set, so for example, and this replicas will create your pods. So if this pod goes down, they come up automatically because the replica set will understand there is some problem and it will ensure that is up and running. So deployment, replica set, and then the pods, and the pod is created on the node. So let's see some example of this. So deployments is how you can manage a set of pods. It means that you want to deploy application. And these would be always be up and running because of the replica set. That's what we call maintain states. So we create deployment that creates a replica set, and the replica set would maintain the state of the pod. And you can update to a new version without any downtime. You can scale up all these features which is required for any live workloads. All these you get it as per the deployment. And how do you create it? Simple example. In Kubernetes, whatever you do, everything you use a YAML or a IAC method. So example, there's an API version, kind deployment, my name of deployment, the label. Now this deployment is going to create replica set. You see 3 copies. It means going to create 3 pods, and this will be going to be highly available. And this session is for this is for your deployment session. This is your replica set. And this session is for your pod. And each of the pod is going to have 1 container of Nginx. So if I say now apply this, so I'll say Qt apply. It'll create all these. First get deployment. 3 copies are going to come up. And that will create your replica set. And you can observe it. The name of the replica set would be having the name of deployment. So you see that there's a tail of your deployment. And this would create the 3 pods in here. And each of the pod will get created on different node if you have 3 nodes, for example. Now, if you delete any pod, the pod will come up immediately. But you might lose some data in it because it's stateless. So example, 3 pods are not sufficient for the workload. So too much of workload for the example could be e-commerce websites. So it's a shopping website and too much of shopping people have logged in today. So you might want to ensure that I want to scale up my workloads. So we can just write a simple command to scale up my workloads, or we can modify it. We'll create multiple copies. As it modifying, let me go down. For scaling up, you can scale up to multiple copies. For that, I just need to say scale up my workloads to 2 or 3 multiple copies. It scales up. Now you want to do update, you can do updates. All these are features what we can do with your Kubernetes deployment. Are we good? Any questions on what is deployment? Yes, no?
Hi, Chaitanya. One question from my
Yes.
side.
Yes, please.
So the deployment, what we are, means what you showed right now, will it be on the default side or means how does this deployment work? Means I mean to say, when we run a command for the deployment, so this particular deployment will be inside a default one, or we are prescribing it to our one of the
Namespace.
yes, namespace. Yeah.
Yes. So if you don't mention in namespace, you're not mentioned. It'll go default. So in case you want special namespace, either you can mention the namespace under the metadata. You can mention namespace in here. Or when you don't apply of it, you have to mention the namespace, hyphen namespace.
Okay, so that means like we can manage it from the manifest file as well as from the command line, right?
Yes.
Okay.
For that, you need to have the namespace ready before, and then you can mention this. So it will
Okay.
go and create it. Yeah. And
Okay.
that will
Can you
create,
please,
yes.
yeah, can you please show us a command for that? So that,
For this one,
yes,
pretty
for the
simple.
name with
So for
having a
example,
namespace and for that. Yeah.
I'll just say, so apply hyphen F and the file name. For example, the file name is, let's consider as a pod.yaml, for example. Yeah. You would say namespace equal to test.
Okay.
That's it.
Okay. Okay. Thank you.
Yeah. Okay. So this is about the important component. Now, apart from this, let me talk about some more feature because I think you're interested. So we can do a scale up. Now, let's consider that you had an update version of 1.14.2. Now I want to update it to 1.16.1, a different version. So what we can do is we can do an update using a version command 1.16.1. So we'll create a new replica set. For each version, get a new replica set, and it'll create new pods inside it. Yeah. So these are some features. We're going to create new pods immediately the new version. So right now I'm having 2 replica sets because before we had only 1. So like this, whenever you do an update, it'll create a new replica set. So you can think about in this was 1.14.2. Now since you updated, it will become 1.16.1. If you again update it, will become 18.2. And this would be of 1.14.2, this 1.16.1, and 1.18.2. So I can have a single deployment with multiple image versions, and each of replica set would be of different image versions. Yes, would make sense? Yeah. Now, let me see some use cases about where we use Kubernetes so that you can. So this is I'll share this documents to you all. So we use Kubernetes for lots of critical workloads, for scalable workloads, we use Kubernetes. So mainly we use for containers. With containers, these are features. And these are the important reasons of why Kubernetes preferred very much. First one is anytime you can containerize the code. It means that you can write in a configuration, a YAML file, the configurations. And you can integrate with your CI/CD, self-healing. The pod goes down, they come automatically. And this will help you to avoid outages. And they take very less resources. So containers and Kubernetes take very little resources, will help you to save in resources. Any enterprise which requires, for example, Tinder is a dating company, they have lots of users logging into it. So it has scalability and stability. So I can just say scale up my workload to 100 copies. We'll create 100 applications immediately. Or could it where there's any applications that they have challenges of too much of workload all of a sudden, then answer is your Kubernetes. To summarize, the first one is you can anytime see the configurations in a YAML file. So it is quite easy for you to understand what is going on. Second, you can define where to run your workloads. For example, you have 3 nodes. One node is something could be compliant among the 3 nodes. You can say run it on that specific node. So you have flexibility. And Kubernetes can work with any tool. So let's consider using like Nagios, or for you are using some monitoring tool which is very generic for your company. You can integrate with that. Very flexible it is. Second, containers provide you portability, immutable. Immutable means when you update any applications, it will not touch the existing containers. It will create a new containers or new pods, so that existing applications users does not get affected. And we use YAML files, which is much easier to understand and reproduce. So these are some of the important features why Kubernetes preferred, apart from the features what we talked about. And how do we interact with Kubernetes? We use a command line interface called as a kubectl. So this is your command, for example, kubectl get nodes, then kubectl get pods. We use this command like this. So these are some important concepts of what we saw on the diagram as well as the explanation. Now, what's the EKS? Very brief. Now, when you want to manage all these, for example, let's consider that you want to create, master, and do all these things. Too much of management doing in enterprise. And if you are a development company, you do not want to manage the manager. So this is where we can go for Amazon EKS, which is platform as a service. But in the cloud, they would manage the manager. So AWS would manage the manager. And as a customer, you can either manage the worker nodes, or if you do not want to manage this, even that is also could be managed by AWS. Both could be managed by different models. And the manager would be multiple managers, like 3 managers, multiple managers, and you don't get access to manager. So we can define either EC2 or a Fargate, and the manager is managed by AWS. In this, you have to create your worker nodes and to manage it. In this, even the worker nodes are managed by AWS. And you can quickly connect to the cluster from a client machine, and you can start running your applications. They will do a demo in the end. Now, how does it work? For example, the control plane, this is what we're talking about. It is managed by your AWS. That will have API server, etcd, all these. And this will be running at least 3 copies, 3 masters in at least in 3 zones. And the worker nodes is what you created as part of a node group. So you can create multiple groups. So one could be for x86 architecture, for example. You can create one for x64. Like this, we can have multiple groups, or could Windows separate or something, you can separate it. And inside that, you start creating your pods with the components. So it's all about manage control plane. So you need not worry about managing the master, HA of it. It runs across at least 3 zones. And they also help you to manage worker nodes, like updates, they do it partial, but not complete. If you want complete, then you want to go for your serverless. So control plane is what we're talking about, your main component running across multiple zones. And this is your management component. And the backends are worker nodes. And in the worker nodes, you can create groups in which you want to deploy your applications. That is called as a node group. And in each node group, all the instances, for example, EC2 must be the same type, same configuration, so that if the load increases, it's part of auto scaling. So the nodes can come up automatically. You can create multiple nodes, groups, and define different configurations. So how does it work? So example, in this, you would be having a client machine. So you create a client machine like EC2. And when you log into the cluster or do some operations, like you say kubectl run a pod name, the request goes to one of the masters. And the master in turn send the request to one of the worker nodes in the backends. So you have to create configure EKS, and you say that I want on a pod, create a pod. The request goes to one of the managers in the backend, and it request go to one of the worker nodes in the backends. So this is hidden for you. This is what you manage it. And this is part of auto scaling. The load increases or going to create new nodes automatically. This is what is your EKS using EC2. Yes, any questions? So the managed service. So because of the management efforts reduce, you can quickly release application production. And you can run Kubernetes in any environment. Availability, resiliency, all these are taken care by AWS. And this helps you to concentrate on applications. You can also have a hybrid environments. You'll get lots of options to integrate. Yeah, I'm going to pause. Any questions? Are we good? Yeah. We cannot learn everything in one day, but on a high level, be able to understand about what is Kubernetes, what is EKS, that would be good. I'm good to proceed, everyone? Okay, let me proceed. Now, this is brief about Kubernetes. What is Terraform and why Terraform? We'll learn about that, for which first you need to understand what is infrastructure as a code. So I'm sure that you all work on EC2. We all know what EC2, everyone? If you want to get EC2, for example, what I do, I want to get EC2. I would go to the Amazon console. Then I click on EC2. Then I click on launch instance. I have to mention the name, all they're supposed to do. And if I'm supposed to do the same VM, again, same application, then I have to do a rework. So this is going to be very tedious. And we are looking for automation. That is where we can use a concept called as infrastructure as a code. So in this concept, what we do is we can create either in a JSON or a YAML format, for example, either JSON or YAML, or Terraform has a concept called a .tf. So you can define that I want to create EC2. You mention in this name of it. So you can say test. You can say size, like T2 micro. You can mention the AMA ID, all these things. And then we upload this JSON file. That will create your instance. So tomorrow I want to have the same configuration, so modify it. I can go ahead and modify the configuration inside it. This is called as infrastructure code, wherein as an operations, you think that you're a developer and you start managing infrastructure using the code. So we're talking about this now. And Terraform is one of the leading infrastructure code for your deployments we use. So we can manage networks, we can manage virtual machines, load balancer, anything using these methods. And this helps to having your applications to be deployed on multiple environments with consistency, speed, reusability, all you're talking about in here. The audit changes, all these we get the advantages. In very brief, IAC is provisioning infrastructure through software to achieve consistent and predictable environments. And we have different technologies for this. Wherein, how do you get started? You get started wherein define all of them in a code. So this code we're talking about could be a JSON or YAML, or in Jenkins, for example, you use Groovy, multiple options, or Terraform with .tf. So as a team, how do we know that who's making what changes? You might want to save this templates in your GitHub and do a versioning so that we know what lines were updated. And we can work with this either imperative means a command line, single line, like kubectl run pod, or we can write in a declarative like your programmatic methods. Idempotent and consistent means, for example, if you're trying to create an application, it's already created, it will not disturb the application, or it will not disturb if it's already started. We can either push or pull the configurations of this by using different methods. So these are the different terms related to any IAC methods. And we're talking about very brief about Terraform. We normally use these for deployments. And these deployments, we want to be consistent. And to ensure that you don't want to repeat it, reusable. You also get a document architecture so that you can refer anytime what is there inside it. You can modify it, reuse it. All these are advantages of what you're using IAC. So we use it for provisioning, updates, we integrate with your source control. All these are some of the features using deployments. And Terraform is one of the leading technology, which is a product of HashiCorp, which is used for multiple use cases. We can use it for managing cloud resources. You can manage it for Kubernetes. You can manage AMIs, lots of use cases. Let's see this. So website of Terraform is terraform.io, product of HashiCorp. It's all about automation. They normally talk about cloud. You can also use for on-premises. So you can use it for managing infrastructure code with the cloud or on-premises. You can use it for multi-cloud, wherein you have environment in which you have both AWS and GCP together. You can do it for Kubernetes. You can use it for managing network, for managing images. You want to automate images creation, and for compliance, lots of use cases. So we're talking about very specific to this right now. So infrastructure code is how you can write your infrastructure configurations in a code, and you can reuse and run it. And in here, either you can use a GUI base if you want to go for a paid version. Enterprise, you get a cloud, or we got Terraform cloud, in which you get a GUI method, or you can use the command line methods. All about automation. So let me give a small example. So let's consider you want to start with AWS. The first one is you have to install Terraform. So you install Terraform, and Terraform could be installed either on manually or Windows, Linux, multiple methods. So this is your software on Ubuntu, for example. You update it. You need to get in the GPG keys for secure download of repository, and then we download this, and then we run it. So once it is run, Terraform would be installed. Quite easy. You just need to run these commands. Terraform is installed. Now you want to do some work in your AWS. For example, I want to create a container, whatever is it I want to create. So what I do is I mention the details about what image I want for a container, with size, all the information. And then I initialize. So what will happen when do I initialize? It has to download this. These are modules. I talk about this. You download the Docker specific configurations in the backend, and then I can do apply, it'll create application quickly. This is a very high level, the overflow. We're talking about this now. So like this, I want to manage any infrastructure, it could be my Docker or Kubernetes or AWS or Azure, they can manage. So this is how it works in the back. We're talking about this. So IAC Terraform helps you to visualize what exactly you're getting created in Terraform file. You can recreate the resources. You can scale up the resources, quite secure, and you can audit So you have in the configuration saved either on this local server, or you can save it outside also, or like S3 bucket, you can save it across. So how does it work? So you have to first install Terraform. That is your core. And these are the providers. So providers means, example, you want to work with Terraform with AWS. These are providers like AWS, Kubernetes, could be VMware, all these are providers. So you have to first into Terraform. Then when you do a Terraform init, this information or provider get downloaded onto your local server where your Terraform installed. Then you write in the Terraform configuration files and you start creating a configurations. In the configurations, data is stored in a file called as a state file. So whenever you do some changes, it'll update the state file. And if you do apply, it'll again come back to desired state what it was. So we define a configuration. So this configuration is what we write in TF file. This is going to save your configuration files. And this is your main component, which is going to do all the work in the backend. So how do you start? How do you write languages? So Terraform, you have to use a language called as HashiCorp language, which is very similar to JSON, but not exactly. It's much more easier to write in using Terraform HCL compared to your JSON or YAML. And if I'm a developer, what I can do is I can have something like this in my workspace in VS Code, in which I can have everything clubbed to easily, and I can start making changes. Either you can create a folder structure, or you can have a .tf files using which you can define it. And what a manifest? Manifest means set of files. So you have to use HashiCorp Terraform, and you would define blocks, arguments. So these are the important components of a Terraform. How does a Terraform language look? So you write something like this, a resource, for example, I want to create Azure. So there's a type in Azure resource group, and this is the internal reference that it's going to do. And this is the name of the resource group which you're going to get created in this location. The syntax. So block type, then you mention the top level blocks, block labels. All these are examples. Location. So any configuration would have block type, resources, or it could be your data, or we can mention provider. All these are some blocks. And these are the arguments. So these are key value, very similar to what we use in your JSON we use. And how do you put in some information? You can use some comments so that anyone can understand what exactly this is doing. So in very brief, you have different blocks defined in Terraform. Terraform block, in which you define what is the Terraform version. These are the details of provider like AWS. And this will have details about resources like EC2, what you create. Now, if you want to reuse multiple times, it's quite difficult for you to do all the time. So we can use variables for inputs, outputs, and local scope. You can use local. And this is example, you already have a VPC, existing VPC, for example. You want to create an instance in that existing VPC. So how do you refer the existing VPCs? We can define that in a data source block. That we already have VPC, and from that it will create the EC2 inside that. And modules means you don't want to write all the Terraform files. You have ready Terraform files saved somewhere by a SME or by HashiCorp. You can download it and install using that. It's called the modules. So these are the configurations. You mentioned Terraform block, heart. So let me show you how does it work. So this is your example, how we get started. So I go to Terraform registry. So this is where you can find all the information about Terraform can work with which providers, which modules. all the information. I click on Browse Providers. You see here, all these are different uh, providers with which you can integrate with your Terraform. And all the categories you can filter on the left side. It supports a cloud-based, non-cloud, storage, network, all of them. Now let's consider you want to work with AWS with Terraform or Kubernetes. I click on Kubernetes and I have to use this provider. So this must be referred in your TF files that this is your required providers, which version of it, this must be updated. And then we can start using documentation of it. It has very good information about how to create which resources. So you have to update this for information. So example, on create a namespace. This is your resource name, and the example reference is going to create your namespace. And for every object, example, you want to do something else, the left side, I can go ahead. I want to auto scaling, for example, I click on auto scaling and I click on the resource name and I have a syntax defined. So this is how you can refer the syntax and you can start using that inside here. Just similarly, if you want to use something else, I can go back. I want to for AWS, I go for AWS in here, and then there's a provider. To add this. The documentation would have all the details about how to create resources of it, the information. Yeah. So this is what is your Terraform registry. And once you define any resource in your blocks, it'll get downloaded in the backend. Yeah. Any questions? Yes, no?
I think
Yes,
we
Tim.
have to, yes, I think we have to explore a little bit more so that we can grasp whatever you tell.
Understand. Yeah.
You know,
Yeah.
so
Understand.
many things you have explained in a quick way.
Hmm.
So
Understand.
that's
Understand. I can do that. No issues. But on a high level, are getting a picture.
yes, yes, absolutely.
Yes, yes. So please understand, you cannot be an expert in this. You're just in a concept. So on how, okay, let me again talk about it. So Terraform registry is wherein you can get in the information of which provider, how do you work. If you want to know, I need to go to the registry. So example, let's consider that you want to Terraform for your deployment with Kubernetes. So I need to go in here. I click on browse providers, and then I will go for Kubernetes. Now, if I want to integrate this, I have to get in this information, and this must be defined in a Terraform configuration file. This must be referred. And how do I create resources? For creating resources, you go to documentation. Example, you want to create a namespace. So you have to mention the provider details in a Terraform, and then you start creating the resources. So these are some example left side in which you can go ahead and do it. Look at a config map, for example, we have some specific configurations. Like this we write. Same with AWS, because I think you all are good in cloud. So if you want to AWS, let me go easier one for you. AWS, I go to documentation. And I want to create an EC2 instance, for example. So what I do, I'll go for EC2. So let me go into EC2 specific. So this is my EC2. Now I want to create an EC2, for example. Instance. So now I need to use this syntax, resource, AWS instance, and then internal reference. And I already have existing AMI from which I want to create. And this is your AMI. And it'll go ahead and create from it. So like this, we can define different resources. Similarly for VPC, if you want to know, so I go on to VPC. You go down somewhere, or S3, for example. I go to S3, I want to create a bucket. I go to in here and we'll be having some syntax. The bucket name, and inside this could be a tag named environment. This is how you write. These are some examples. So you would be having multiple blocks. So first mention different versions. Require provider, for example, using for Azure in here. Then the backends. Examples. Now the providers, what we talked about now, all the providers. And you can work with any providers. So how does it work? So you first install Terraform. It on the flow of it. So first install Terraform on the local machine, for example. You would be having a Terraform CLI. So you have to install Terraform and you would be writing a configuration. Let's consider you're writing a configuration in a project folder. So your folder named as project, in which you're saying to create a resource, could be a namespace. So you have to do a Terraform init. It'll go and download this. I'll show you a demo. It'll go and download this on the local machine, the provider. Then you can do validate to check whether the syntax of what you wrote is correct or not. Then you want to know what exactly is getting created. A Terraform plan that lets you know that it's going to create a new namespace, what type, all of them. And you can also save the plan to outside. You can have review of it. And then we can say apply the creative resource. So this is your flow. You install Terraform, write in your code files, put Terraform in it, Terraform, validate, plan, and apply. So these are the components. I don't want to destroy also, delete everything. So first one is providers. And then we're talking about using resources. Registries. This is your official. So in your registry, we have either official, which is managed by Terraform itself, HashiCorp. Verified is third-party companies, they are partnered, and community is some open source, or you can create your own, also you can create it. And these are some examples. So in resources, you say resource type. This is a local reference. This is not the name what you see in your screen once you deploy it. This is for local reference. And this is what you can define that I wanted 2 copies. You can define some arguments. Location. These are some examples. So create a resource. You can destroy resources. Update resources, not just creating, you can update, destroy, all these are some, and recreate. And where all this are saved, that is called a Terraform state file. So it'll have a format called it .tf state. And you can see the information of this. So how does it work, all of them? See, I think the same is coming here. I think it's better. Went back. Good. First init, then we do a validate, and then we do a plan, then we do apply. If we don't want, we do a destroy. This is your workflow. So in it, it'll go ahead and download the provider file. That's what is the main. Validate is going to check your syntax. And plan is going to give you an idea about what is getting created, either create or update or delete, what you're doing. That is what you see a plan, like a preview. And then you can say to apply, to go and create what you define in your Terraform. If you don't want it, I can say Terraform destroy it, create your. And for each and every step, you'll get a confirmation for planning, applying it. You can also save the plan outside to different file, and then you validate it. This is your workflow. Any questions? Any questions, team? Are we good till here, everyone? Okay, let me do a demo. The demo is very, we'll do a partial demo because the demo is very big. Now, this is your, I'll get a link also to you all. I'll explain and then we'll do a demo of it. Please access this link. Okay, can access the link now. We'll do a small demo for partial because. So this is a link in which we are going to see about how you can deploy cluster of EKS in here. So we can either do a EKS or AKS for Azure or GKE and a generic one. So we're talking about EKS example. So what is EKS? So EKS is the open source scheduler. And in this, I'm going to give an example. One step is not working because lots of things are required, but I'll tell the workflow of what happens. So for doing this, you need to have a good idea about what's Kubernetes and kubectl. And this is your folder where you have in the code files. And this is your configuration file. So this has the details of Terraform Kubernetes, AWS, and this is of your Kubernetes. So both must be referred. Now, where do you want to store in the configurations? So we're storing locally, but for some reasons it's not working. I'm working in the back, I'm not sure. You're storing the configuration this location. And this is your cluster information. Provider, all this information. And since we're talking about two things, we're talking using SSOs. SSOs are for single sign-on. Then you'll get a token in the backend. Now there's a configuration. We do Terraform in it. It will download the provider of it, but we're getting some error. So now how do you get a resource? For example, say resource deployment, name of the internal reference, and this is the name going to get created with this label. And I want two copies. So I say replica sys2, the label. So you see here, the label names must match in your deployments. The same label must be there for your deployment, same for your replica set, and this is for your pods and the container. So once we get these are resources for your container. So this template is going to create a deployment, replica set, and a pod of Nginx with these resources. And do apply, we create all the resources. That's what this. But we are getting some error because of EK some changes. I'll just show in a high level how that will work. So for doing this, what you are supposed to do. Now, if you want to start with this first one, we have to install Terraform. So then update, apt update. then install this, then these are keys for installing. And then after Terraform is installed, you have to go ahead and download the access keys. So example, in AWS, install CLI, AWS CLI, install AWS CLI. Let me talk about the flow of it and then we'll do a demo. The first one, for this, what I've done is I've created EC2 of Ubuntu, for example. Next, I configured AWS CLI. So install and configure. Then third step is you have to install Terraform. These are prerequisites for this. So let me log into the Ubuntu machine. I'll show you all these things. So this is my VM. I'll log into it using the private key of mine. So SSH, auth, credentials, browse. This is a private key. I logged into here. Okay, I logged in here. So let me show you what all I've done. So first I installed CLI. So I confirm the CLI version. So you have to have a CLI working. First requirement. Then you test it. AWS S3 space ls, for example, is working. So you have to install CLI and you have to do AWS configure. We all know how to work with CLI on high level, everyone. Do you understand this? Do you work on cloud CLI or you're new to this? Yes, team. Do we know what is CLI? Okay, we're good with this. So after this is done, insert Terraform, then Terraform -v, Terraform version. Now, when do Terraform and press enter, I see all these commands. So init, validate, plan, apply, and destroy. And it's quite easy. For example, you want to know any command, you can say Terraform init -help. It'll give you all the steps about what are these. All these are prerequisites. Now, this is a folder in which I have in this. I'm getting some error. So this is your code file, which is as per the demo what I showed you, the take file. So this is your TF file. The TF file, this is your providers. And I tried a backend of ST not working for some reasons. I'm trying still, but not working. The local. And you mention the AWS, all they're supposed to do. What is want to create, all they're supposed to do. And the first step, what you're supposed to do is you're supposed to do something called a Terraform space init. Do Terraform space init, it will download the provider from the backend. And it creates a dependency file, which has the required version of what provider you used. So now if I do a ls-al, you would see a .terraform. Now, if I go into .terraform, for example, this is where it downloads the provider information registry. And inside this, if I go to HashiCorp, AWS, you see here. So the provider got downloaded. So Terraform init is what downloads the provider information, what we mentioned, which is mentioned the first line, for example. Now, after you do this, if you want to format, we do a command called as FMT example. If you don't find anything, it means already done. Then I do a Terraform validate to check the syntax is fine. You won't check syntax of it. It's all good. Then I do Terraform plan. I'm getting some errors, and they talked about the local is not taking, and do Terraform plan. The Terraform plan is going to go ahead and give you the plan about what is going to get created. Yeah. So I'm getting error, for example. So what I'm going to do is right now, I need to go and modify this. So this local is not getting taken. I'm not sure, already done in the morning. So you can also add in some comments like this in case you want to skip something like this. So these are some methods. So yeah, this is not running in right now, but this is where you can put in some comments. You can make the changes because EKS requires lots of rules to be done in the backend, and that is not for the demo in here. So once you do a Terraform apply, this is going to create your configuration in the backend. This is what is going to happen. This step is what I'm not going to do it. But do a Terraform apply. It's going to download, or it's going to create all the resources. It'll say what you want to create. Yes, yes. They create all your components. And I can see it up and running. This is a simple example about how we can use with your AWS. Now let's consider you want to use with your Azure. We can also create a AKS cluster in which you install Terraform in your Azure VM, for example, and then you configure CLI, you configure kubectl, this, and you can start writing your configurations, same like what we talked about, and you would say apply and init, and these could be done. Same applies for your GKE. So for every provider, the different methods for provisioning GKE and all. So there's one method we can use. Yes, team. Any questions? This is in very brief about the topic what I asked for. There's some EKS roles permission getting a error. That reason I'm not going to proceed in there. The next step. Any questions otherwise on the workflow? Everyone? Any questions? We got any questions, team? Anything you want to talk about, me talk, or any use case you could have, I can speak on it. Yes, no? Okay. Now, how do we, what are the best practices? Always use different code. For example, if I'm creating my VPC EC2 and all, I'll have one for, could be like a VPC. You might want to have EC2, separate one for a provider, like this. And start creating a folder structure. And store Terraform state. So you do not want to store the configurations once you run it in the same machine. You can push it to the store to a S3, for example, or we can push it to Azure blobs, or you can use Azure Cloud. And use automations with. So Terraform is just one part of your deployment. So in a CI/CD pipeline, you can refer this for your deployments. And auto scaling, you want to start using across so that resources are highly scalable. And you want to secure, we can use like Vault technology. Using it, you can ensure that the password you don't put in your main file, you can put outside for it. And to understand how is everything working, you want a regular monitoring and see how the resources are behaving. So these are considerations we want to follow if we want to integrate Terraform Kubernetes together. Yes, team. I think I'm done with at my end. Anything you want to ask? We still have time. Thank you. Others? Okay, Hari is good. Okay, yes, Ramya, I'm done. Anything you want to address them? Or Shruti? Are we good to close if you have no questions? Supriya?
Chaitanya.
Yeah,
Yeah.
I'm done. I'm done. So they're not asking any questions. So how do you want to close the session? Thank you,
Yeah,
Arif.
sure. 1 second. Just give me a moment.
I'll stop. You want to share something?
Yeah, I'll be sharing the feedback form.
Yes.
Just give me a moment.
Sure. I'll stop sharing.
So I request everyone to please fill in the feedback form. So with that, we come to the end of the session. Thank you so much, Chaitanya, for this
Thank you.
insightful and engaging presentation. We've covered a lot of valuable material today. I hope everyone have got a deeper understanding, and thank you for your participation. Thank you so much, everyone.
Thank you. Bye all.
Thank you so much.
Okay, I think we'll give some time for the to take a feedback or yeah. Hi, thanks, Supriya. I'll leave the session. Bye-bye.
Thank you, Chaitanya. Thanks, everyone.